Hey everyone, in today's video we're going to build a custom air conditioning system from the ground up with the help of today's sponsor, Coldhose.com. Coldhose.com is the #1 place to find anything for making an air conditioning system. They generously send me everything I need to make air conditioning happen for my LS swapped Jaguar XJS, which is behind you. This is going to be a very comprehensive video. I'm going to talk about how air conditioning even works. I'm going to talk about the parts that go into making the air conditioning, all the different fittings, hose types, all the lingo so you can be familiar with what you actually need to buy. Then we're going to go into how you can find this stuff on coldhose.com, and then we're going to assemble the hoses, pull a vacuum, add refrigerant, and see if the air conditioning works. Alright, so real quick, how does air conditioning even work? The most basic way I can describe air conditioning is if you have an aerosol can. When you push this down and you relieve all that air out of this can's going to get cold. Why? It's because you're reducing the pressure. Now, conversely, if you were to take your standard pancake compressor that you've got in your garage with the unit on top, and you turn this thing on and you see the meter go all the way up. If you were to put your hand on this metal tank right here, you'd feel that it is warm. That's because the pressure is going up. So what's going on here? You're creating heat energy right here. And right here, when the pressure goes down, it gets cold. So now let's take it a step even further. If you were to shake this can and listen inside of it, you would hear a liquid. So basically what I'm trying to say is, depending on the pressure and temperature of a substance, it could either be a liquid or a gas. Refrigerant is no exception. This stuff inside of here right now, hear that? It is a liquid because this is at a very high pressure right now. And when we release that refrigerant, as we're going to see later in this video, that can's going to get real cold. Why does this matter? We can continuously compress a gas, create the heat, we can cool that heat off, turn it into a liquid, and then we can let that liquid boil inside of a different coil, which means it's getting cold. So it's taking heat out of the air. It's taking energy out of the air and making the air colder around it. It then goes back to a gas, it gets recompressed, and then we can do that cycle all over again. So I'm going to make a very, very basic drawing of an air conditioning system. So right here, what we have is the compressor, and our refrigerant's going to be going this way. We're about to make a path. We're going clockwise along this page. So what's happening at the compressor inlet right here is we have a cold gas. I'm going to draw up the cold gas like that. So we'll say gas equals da-da-da, and then the liquid equals stuff like that. We're at the compressor, we have cold gas at a low pressure. So then what we're going to do is we're going to compress that, and what's going to happen is we're going to have hot gas at a high pressure. So what are we going to do with this high pressure gas? We're going to put it through a coil called a condenser. So you know how your beer bottle's going to get kind of wet when you're outside on a hot summer day? That's water vapor condensing on your beer bottle. So what's about to happen here is we're about to have a high pressure liquid. So now we're going to make our liquid line. And here's where things get very interesting. Next, we go to a thing. We're going to call this an expansion valve. And what this expansion valve is doing is it's bringing our high pressure liquid to a lower pressure. So now we are at a low pressure liquid. What are we going to do with this liquid at this lower pressure? We're going to put it through an evaporator. And what's happening in this evaporator core is this low pressure liquid is becoming a low pressure gas. So, and here we are, back to the low pressure gas. So, extremely crude, that's how it works. You've got your low pressure gas, you compress it to a high pressure gas, take the temperature down with your condenser coil, which is that thing in the front of the car near your radiator. Now you got a high pressure liquid. And then we have a valve that's going to be kind of the bridge point between the high pressure and the low pressure. It's going to take that pressure down, and then this liquid is going to boil, or evaporate, I guess, inside of this evaporator core and become a gas again. And this just does this all day, over and over. So briefly, if you have no idea what I just said, the compressor is on your engine. This could be found on the engine. It's got a pulley, the belt is running it, and it's got a little clutch that can either turn it on or off. based on whether the car wants the compressor running or not. The condenser, this is near your radiator, and it's actually a condenser coil. Basically, you're passing the refrigerant as a gas through this big giant heat exchanger, just like your radiator in the front of the car, and that's what's allowing this gas to cool down. The expansion valve can be in various places, or the orifice tube. It's generally near the firewall, or it could be just inside the firewall. This is a very small component. It's not very easy to find it. The evaporator core, this is inside the car, buried in all of your controls and the airbox and stuff. So that's where this is. And then you've got lines coming out of the car back to here. There's also two other components that you'll see in the air conditioning system, but they're not represented here. They are receiver dryers and accumulators. They're just kind of like a cylinder thing that sits in the car, and you'll see the refrigerant lines going to those things. We're going to talk about where you'd see each one of those in the next two things right here. Now, I mentioned the expansion valve. There's actually two main kinds of automotive air conditioning systems for our purposes. There's expansion valve and orifice tube. Expansion valve and orifice tube are the things that take your pressure from high to low, basically. It's two different means of getting to the same place, and they work a little bit differently. We'll get into that right now. So we're going to start with expansion valve. So with the expansion valve, we have a few main components. We're going to start with our compressor up here. Next we're going to go into our condenser core. After this we're going to go to something called a receiver dryer. After the receiver dryer we go to the actual expansion valve. Over here we go to our evaporator core, then we're going back to the compressor. So just briefly, we are high pressure gas, high pressure liquid. You're still a high pressure liquid right here. And then in the expansion valve you become a low pressure liquid. And then after the core you are a low pressure gas. So the way this system works is it's using the expansion valve, which is cool for a few reasons. It can variably change how much it is decreasing the pressure per se. So the compressor is always running as long as the computer or sensor is seeing the proper pressures in here, and the expansion valve is constantly varying based on outside temperature. It's getting that pressure difference kind of perfect for what we want to see inside of here. And the way it's going to work on the car we're building is we have a sensor right here. And what's going to happen is the computer is reading the pressure at this sensor, and it's looking for certain values, and it knows that if things are too high, it's going to cut off power to the compressor, because what the computer is controlling is a relay that allows power to go to the compressor. So this is going to be reading that in this system that we're about to build. If it's too high, it'll cut it. If it's too low, it'll cut it as well, because you don't want to run the compressor with no refrigerants inside of here. This is, in a nutshell, how the expansion valve system works. Now let's look at the orifice tube system. So again, compressor, going to condenser coil. Then we go directly to our orifice tube. Then we're going to go to the evaporator core, and then we go to something called the accumulator. So again, high pressure gas, high pressure liquid, low pressure gas, and low pressure gas. So what's really interesting about this is the way the computer is going to work is it's going to be reading the low pressure end. It's going to be reading a sensor on the accumulator. And what it's actually going to do based off of the pressure on the sensor is it's going to turn the compressor on and off based on the pressure on here, because this orifice tube is fixed. It is doing a fixed pressure differential between here and here. It cannot vary like the expansion valve can, so it's fixed. So basically, if the evaporator core is getting too cold and we're about to get like ice on it or something, that means this pressure is a little bit too low. It's going to cut power to the compressor based off of the reading on this sensor. It'll let the pressures kind of equalize a little bit, let this come back up, and then it'll turn it back on. It'll bring this pressure back down. It'll keep pushing the refrigerant through. The other difference between these two is the expansion valve has a receiver dryer on the high side, and the orifice tube system has an accumulator on the low side. They both look kind of like this. This is a receiver dryer that we're going to be using for our build, and the accumulators look similar to that. That may have been a lot of information that may have sounded kind of confusing or overwhelming, but what if I told you all we have to do to make the air conditioning work on this project car is build 4 hoses. Put them on your car, pull a vacuum, add refrigerant, and you've got working air conditioning. Hopefully it's that simple. And it is going to be that simple at the end of this video, but there's so many things we need to know before we can go ahead and do that. What fitting do I use? How do I know what fitting I need to put on what hose and which hose size? You know, I've got 3 different hose sizes here. There's a 4th one out there. You're going to understand all of that at the end of this video, so buckle in, get ready. It's going to be very fun. Okay, so just to provide a visual aid, this is my V8 swapped Volvo 240. It's got a Lincoln Mark 8 engine in it, and it uses Lincoln Mark 8 air conditioning control for the most part. We'll get into control later. I just want to show you practically, you know, how this was done. By the way, Coldhose helped me out with this one too. I actually learned how to do this with Coldhose on this car. So let's start at a compressor down here. The compressor is that pulley down there beyond the hoses. Now you see 2 lines right here. It's tough to see, but those are actually connected to the compressor manifold. So this one's coming off of the evaporator core. We've got our low pressure gas. So we're going to start with the high pressure gas, which is this one right here. What's happening here is we have the high pressure gas going into this hose right here. So I got a 45-degree fitting with a spring lock connector right there. I'll get into all this in a minute, don't worry. And where that's going is underneath the airbox, and then I had a 180 splicer, and it's coming around through there and bending. Coming into here, there's our high pressure port. That's what we use to check the high pressure side of our AC, and then it goes into the condenser coil. Also under the airbox is a high pressure sensor. Very tough to see, but we will talk about that later. So the condenser coil is this coil right through here. It's the first one you see on the car. That is not the radiator, that is the condenser coil. So we start up top here. We have our high pressure gas coming right there. Then down further you see a line with some foam insulation on it coming off of the condenser coil, which is in front of the radiator. That is our liquid line. It's our high pressure liquid, and that is going along the frame rail essentially. It's going to the back of the vehicle. It's entering the firewall just underneath this line right here, which we'll get to in a minute. I'm not about to pull back my interior because we're going to go into more detail with the different system in the future as we build it, but inside of here is the orifice tube. The evaporator core is inside of that box there, which is where things get cold, and then after that it comes out back through the firewall to right here into this big hose right here, and then this hose connects to the accumulator. The accumulator has the low pressure cycling switch on it like we talked about in the diagram, and then this thing right here goes all the way back to the compressor so we can do it all over again. So this is essentially what we're going to be building for the Jaguar in the garage, but it's going to use expansion valve. Alright, so here we are back at the Jag. It's going to be the same thing, except it's going to use an expansion valve instead of an orifice tube. So, like we looked at in the Volvo, compressor right around here is on the same side with this LS engine. We've got a manifold. This part actually came from Coldhose. We'll talk about that in a minute. You can see where we want to go straight out to our condenser coil. Condenser coil is kind of hard to see, especially since we've got the front hinged hood, but it's that coil right there. And that condenser coil uses some special fittings. There's one of them right there. You can see the screw kind of in there. That's going to be our outlet. On this car, we're going in on the bottom. So that means right down in there to the special GM style fitting. I am sorry about the camera, but it's just kind of what we're working with right now. So we got to build one line from there to there. Easy. We'll get to the details of that in a minute. Next, we're going up here to the condenser coil outlet. So now we're at our high pressure liquid. We're going to go from there to about here where we're going to mount this receiver dryer. Because this is an expansion valve system and we want to use a receiver dryer. I think it'll fit well somewhere in this area. We'll figure that out. Next, we want to come out of that receiver dryer, which you saw. 2 fittings on top, and there's a pressure port too for a sensor. We'll get to that. We need to go all the way from there, along the frame rail, across the firewall to the expansion valve, which I've already installed on the car. I did that when the engine was out because, well, look how much easier it is to get to when the engine's out. Very nice. And that tape is to keep dust out of the inlet. So that's our expansion valve. We go in with our high pressure liquid, and then that becomes our low pressure liquid at the expansion valve. The expansion valve is actually connected directly to the evaporator core. And the evaporator core, just like on every other car, is somewhere in there. We can't see it, but it's in there, trust me. That evaporator core has an outlet, which we have an old hose connected to right now. You can see it kind of threaded on there. I just have that there for keeping dust out. It's an old hose that goes to nothing. So then we got to go from there all the way back, similar path to the liquid line. We're going to come back to the compressor manifold right here. So that is the plan. We haven't even talked about high pressure port, low pressure port, sensor, control. How is this all going to work? Let's explain that right meow. Welcome everyone to Coldhose.com, the sponsor of today's video, who has generously sent the fittings, parts, etc. that we're going to need for building the air conditioning hoses in this video. So I just want to take this moment to kind of walk through this website, how it works, explain some of the lingo, and what you're going to need to know for building your hoses. And what's great is we just get to start on the home page right here. So we're going to talk about the different hoses right here. We have standard barrier hose. So this is really, really good stuff right here. This is basically explaining what size hoses you're using where. So when we were looking at the Volvo and we looked at the hose that went from the compressor to the condenser, it was number 8 size, because this is what you want to use going from your compressor to the condenser. And we're going to follow these same rules with the Jaguar stuff. Then once we're coming off of the evaporator, going back to the compressor, we're going to be using number 10. Now I will note this, on the Volvo, it actually uses number 12 because it is an old application. The Jaguar's an old application also, but it used number 10. So really, this is up to you. I would use number 10, but if your application for some reason wants the number 12 for the correct fittings going into your things, I would use number 12. So now we're going to talk about reduced barrier hose and reduced barrier fittings. So reduced barrier hose has the same inside diameter as your standard barrier hose, but the outside diameter is different. So basically it's just a thinner wall thickness hose. We're going to be using standard barrier for everything we're doing because that's what I have the Crimp tool dies for. So now let's go down to different types of fittings. The fittings we're going to be using in this application are O-ring fittings. So you can see that this female fitting, it's got a captive nut, it's loose, and it's got the O-ring sitting right here where these black dots are. This is a cross section. Then over here we have the mating fitting, male insert O-ring. So this part goes into there, and the nut screws onto these threads right here. This is what we're going to be using for everything in the Jaguar, but we may have noticed in the Volvo we have some push-to-connect fittings, and that's because in the Volvo I used certain products that were out of a Ford, and Ford likes to use these push-to-connect or spring lock fittings. So when we're buying this stuff, we're going to be using mostly this. You saw this in the Volvo. You may see these other ones depending on your project. So now that we understand the different kinds of fittings and the different sizes of hose, we're going to go up here to fittings, go to bead lock, and click O-ring. Now here's where everything is at. This is where I went to find just about everything I need. So here's the different kind of fittings you can buy. First of all, bead lock is talking about this thing. This is our little crimp fitting that we're going to be putting the rubber hose through and crimping onto with the crimp tool later in the video. So let's just start up here real quick. You have 90-degree kind of a sharp angle right here for a female O-ring. You've got 135-degree with a pressure port. We're going to use one of these later. 45-degree straight. 90-degree straight with a port. 45 with a port. 90 with a port. 135 no port. 135 port on the other side, and even 180. So there's a lot of different fittings to choose from here. So let's say we've decided we want a 45-degree female O-ring fitting, and it's for our liquid line, so we know it's going to be number 6 hose. and we want to figure out which one we want to do. We notice that reduced barrier hose end fittings have red, and they are either RB or SR. The thing to know about Coldhose fittings is that they are sold in either aluminum or steel. So I just clicked both of these. I opened new tabs. Let's look at the SB 1311. This is the steel fitting. If we go over here, the BL 1311, this is the aluminum fitting. I asked Coldhose what's the difference between the steel and the aluminum, and they said the aluminum is good for just about any light-duty regular automotive application, whereas with the steel, that's going to be for your heavy duty, like, you know, big heavy trucks and stuff. So all the fittings I bought started with BL. So let's get out of there. Let's say we're on our suction line and we're going to use number 10 hose, and we need to make a 90-degree bend with an O-ring fitting. So let's go right here. Female O-ring 90 degree. We're going to go down to where we see number 10. So we see number 10 90 degree O-ring fitting. SB is for steel. So I want the aluminum. So I'll go right here. I'll open this in a new tab. I'll check it out. It is the aluminum number 10 90 degree fitting. So that's kind of how you find stuff. You're going to choose these based on, you know, kind of the exercise we went through earlier. Like we looked at, you know, where does each hose need to go? What does each hose need to do? You take note of that, you make a list, and then come on here and pick out every single one. If you need to get crazy, let's say you need to go from the number 6 O-ring to a number 8 reduced barrier, they've got it. Or you got to go from number 8 to number 10 reduced, or number 8 to number 10. You know, just about any combination you can possibly think of, they've got it on here. And if they don't have it on here, they can probably make it custom for you. And that's what happened in this video. One thing that I needed for my application was custom condenser fittings. So what did I do? I went here to fittings, went to custom fittings made by us on request. If you go to the bottom here, you can click this. And basically what they'll do is if you send them hoses that have the fittings that go to your condenser, which, you know, I needed a hose off of a Yukon and another hose off of a Camaro to get it right, they will weld on either an O-ring male fitting. They can do whatever you want. I had them weld on a crimp fitting, so I could just crimp the hose directly to what they made. And that way I had less seals to worry about. So, you know, see, like with this, you've got a seal up here where the O-ring goes, and then a seal down here where it connects to the condenser. You can eliminate that by just putting one compression fitting on the end here. I thought that was a good idea. They got it done for me, and it works great. So that is my brief tutorial of coldhose.com, your number one place to find anything for an air conditioning system that you're about to build. Now I want to talk about air conditioning functionality beyond the hoses. Like, how do you actually get this thing to work? How do you select the main components like the compressor, the condenser, all that fun stuff? Okay, spoiler alert, the hoses are made in this scene. Everything's done, but we got to talk about this because it's really important to understand how we got here. So like I showed you earlier, there's 5 main components in here. We've got the compressor, we've got the condenser, we've got the receiver dryer, it's right here. We've got the expansion valve buried in there, and we have the evaporator core inside the car. How do we choose these? Let's talk about the compressor first. The compressor, it's important to know what engine you're working with here. This is a GM LS based engine, so everybody knows with the LS engine, everything's compatible. Like the bolt patterns are the same. So with these compressors, this one has it so the suction and discharge ports are on the side, kind of like right here. And I can put this fitting on here that Coldhose sells, and then have the hoses go straight out, kind of like this. That's convenient for this application. You might want the suction and discharge to come out of the back of the compressor. That might work better for you. You might have more room with what you're doing if it were that way. But that's not how I chose to do it here. So the best thing I can tell you to do, really, is go on Rock Auto and think about, you know, what cars had the engine you're using. Look at the AC compressors for each one of those vehicles and see the differences. Make sure the bolt pattern is the same, but take note of where these fittings are on the compressor. Are they on the side? Are they on the back? Are they on the bottom of it? The top of it? Where is it? On the Volvo, I'll cut to some footage of that. The fitting was on the side. And with the Lincoln Mark 8, it had a little manifold on it that had the little spring lock fittings go basically straight out kind of like this one does. And that was really good for my application in that car. So I went with the original Mark 8 compressor and the Mark 8 manifold for the spring lock fittings. So that's how you decide what compressor to use. It's really just a space constraint thing. You know, how is it best to get these hoses off of the compressor? Next we got to talk about the condenser. So like I said, we can't really see the condenser because of the front hinged hood, but it's in there. And the reason we used the condenser we did on here is because it slits in the radiator really nicely. For the Jaguar XJS, if you're going to do an LS swap, the F-body Camaro, so like from the 90s to 2002, the fan, radiator, and condenser assembly kind of all sits together. So I'll show you, like this fan right here, there's a little tab where it's sitting in the radiator. So that's fantastic. So, you know, the fans sit right in the radiator, it's designed for that radiator, and it's the exact same thing going on the opposite side of this radiator. We have the Camaro condenser, it sits right in. The only downside to that was we had to make custom fittings. But that's not an issue for us because Coldhose has our back. Coldhose.com can make custom fittings like we just talked about. So you can see it right there. This is actually a Camaro hose that I bought new on Rock Auto, and I had them modify it so that it's cut right where this crimp is, and they welded this crimp thing right on there. So then I just crimped my hose to it, and there, I've got a custom hose for the custom fitting. For the Volvo, I used a generic universal parallel flow condenser because with the Mark 8 donor, I used that radiator, but the condenser didn't quite fit right based on what I had to do with the radiator cross member to get it to work. So that was, you know, kind of annoying. I had to make my own mounting brackets, and they're not that great, but, you know, they're working. And with the universal condenser, it's just got standard O-ring fittings on it, so it was really easy to get the correct fitting and just go right from there, crimp on what I needed, and go straight to the orifice tube. Now, this car, like I said, we're using the expansion valve, so that means we need to go to the receiver dryer. The receiver dryer on this car, I chose this one because it had a 10mm pressure port for the sensor. So there's our sensor that's going to our computer, and it's telling the computer what's going on the high pressure side. And that's all the computer needs in order to run the air conditioning for this car. I could have chosen to put this sensor in the line as like a splicer, but it's a lot cleaner to just put it right here on the receiver dryer. It looks like it's supposed to be there, and you know, it's a lot cleaner than having like a splice in one of your flexible lines. So that's why I chose to do it this way. And you know, the receiver dryer, it fits in the car fine, you know. There's lots of space here, anything would have fit, so it didn't really matter too much. On the Volvo, we'll jump to the accumulator real quick. That car was a little bit more difficult because I had to make sure that it would fit. So I was looking at all the Ford models from the 90s that used a V8 and looking at all the accumulators, and I saw finally that actually the one I had from the Lincoln Mark 8 was the best. Even though it had these funky hoses coming off of it, it actually worked really well in application. Now, let's go to the expansion valve. Expansion valves are basically standard for this stuff. You just want to make sure that it's for R134A and that it's got green O-rings on it. R134A expansion valves are all doing the same thing, they just might be dimensionally a little bit different. Just make sure you know what size fittings you're using, understand what your expansion valve has on it, and just replace it. Then evaporator core. Evaporator core is pretty easy. I mean, your builder vehicle, obviously it came with an evaporator core if it came with air conditioning, so you're going to want to use that. The only risk with that is, you know, is it leaking or not? Is it still good? In my experience, both this 1990 Jag and the 1990 Volvo had good evaporator cores, and I don't have any leaks. So that's really awesome. One thing I did do though, before I actually went through with the hoses, is I cleaned them out with AC flush. It's basically a solvent, you just kind of pour it through, blow it out with compressed air, and it cleans all the gunk and old oil out of the evaporator core. You don't want that in your brand new system, because as you can see, that's the one used part on this thing. Everything else is brand new. After the evaporator core, you're going back to the compressor. One very important thing you need to know about AC compressors is that they require oil. What happens is oil mixes with the refrigerant and it gets kind of pumped through the system as a whole, and that's how the compressor stays lubricated. I'm recording this part later because I was under the assumption that all new compressors came with oil already in them. That's how it worked with my Volvo. But with this car, The description for the part on one website said it did come with oil. Description on another website said it does not. So the compressor that's in this car right now, it's shown working later in the video. It takes refrigerant and it runs and it works, but it locked up. It completely locked up. It started making squeaky noises, and then before you knew it, the belt was just spinning on the pulley, making a lot of smoke, and yeah, not cool. So what I'm going to have to do is I'm going to have to get all the refrigerant out of here. I'm going to have to replace the compressor. I have to do a flush on the condenser to make sure that I get any metal shrapnel out of there, because when the compressor fails, that's metal parts going all over the place. Not great, but very important to mention in a thorough video like this. I had to make sure I talked about that. So just check your compressor. Make sure it either comes with shipping oil, no oil at all, or it might even come with a full thing of oil like my Volvo did. That was a Denso compressor for what it's worth. This GM Genuine or AC Delco compressor, no oil. Now, the very last thing to talk about with this is control. How are you going to control the air conditioning compressor? So let's just walk through the two examples I have in front of you today. So let's talk about the Jaguar. The Jaguar is using a GM computer, and what that computer wants is a few things. The computer is called the PCM. What it wants is AC request. So what this is it's basically a 12 volt on-off signal telling the PCM, hey, run the compressor, or hey, don't run the compressor. 12 volts, it'll run it. No volts, it won't run it. Very simple. Now, obviously, it's not going to just run it based on this. It needs to have some information. So what does it need? It needs a signal from the pressure sensor. I think we actually call it a pressure transducer. So what the pressure transducer is going to tell the PCM is whether there's enough pressure to run the compressor. Because if there's no pressure and it just runs the compressor, well, the compressor is going to get a little hot. It might lock up. It's not going to end well. If the PCM has a valid AC request, and it sees that the pressure inside is okay, then what it's going to do is it's going to send a signal to the compressor relay. And the compressor relay will then complete the circuit to the compressor. So basically I have this thing tied into the Jaguar's original air conditioning, so it runs just like it would stock. This thing I just showed you, I just put it on the dryer because my dryer that I bought has a pressure transducer port. So we have those two things. We send the wire to the compressor relay and it turns on the compressor. Very simple. Now, this can get far more complicated, and I'm about to make this a lot more complicated by telling you about how the Volvo works. The Volvo is using a Ford computer. The biggest difference between this computer and the Ford computer is that it's using a much more complicated computer network. There are multiple modules in this system that I'm about to draw that don't exist here. So what we've got here is the PCM, and what the PCM is looking for is it's looking for a signal from the climate control module. And how does the climate control module know what to do? Well, it is connected to a sensor, and that is the low pressure sensor or the AC cycling switch. So already this is very complicated because we have this switch. It doesn't go to the PCM, it has to go through this climate control module, and then this module takes this switch signal, converts it to a CAN bus signal that the PCM recognizes. So I don't know how to mimic this. I can't just get rid of this module and have the switch go directly to the PCM. I need some translator here, and the easiest thing to do is just use the module. So now that we have this, the PCM can then send a signal to something called the Variable Load Control Module, or VLCM. And what this is it's basically your radiator fan controller. It can vary the speed of the radiator fan, whereas this thing, all it's doing is just turning it on and off basically. So this thing can turn the radiator fan at whatever speed it wants, which is really cool, but it needs other information too. So we have a high pressure sensor down here, and this VLCM is reading this sensor so it knows how fast to run the variable load control module and turn the fan really fast if it needs to. And then what this finally does is it controls power to the compressor. This is really annoying. This was kind of challenging to figure out. I had to go through the service manual a million times to finally understand this, and I might even have this high pressure sensor thing wrong still. But it can be simple or it can be complicated, like this. All I can say is that you need to understand your donor vehicle, your builder vehicle, how it worked on each one of those cars, and how you can combine those two systems to work in a way that you'd like them to work for your desired build. And I should also write these guys here. This is an expansion valve system, this is an orifice tube system. So in my opinion, the most simple way to do this is probably this one. You know, you've got your on-off switch, you've got your pressure sensor, you've got the computer that knows what to do with those things, kicks on the relay, kicks on the compressor. This I don't recommend, but it's what I had to do to get my desired outcome. So what do you say we stop talking theory and actually build something? Before we get started with all of this, I want to address the evaporator core, because that's the one thing that's not being changed on the car. It's the one thing that's original. I cleaned this out when the engine was out, and I want to show you the video I took when I did that, and just kind of talk about what I used, how I did it, and you know, why it's so important. So what we're about to do is use some AC flush. I get this on Rock Auto. There's the part number and stuff. What I did with the Volvo, and you know, 3 years later the air conditioning still works, is I basically just hooked up a funnel to here. I mean, whatever. I took an old hose and cut it, and then I just kind of dump this through, let it drain into this bucket. What doesn't come out, I will take compressed air, I'll put it on this hose instead of the funnel, and then I'll just blow everything out when it's all done. And that's where it might get messy. So let's see what happens. That's about half the jug. We'll start there. I'm going to get the compressed air and just try blowing some stuff out. I gotta get a better angle. This is funny. Just remember, this stuff is clear when I dump it in, and now when I squirt it out with the compressed air, it's basically straight up yellow. So yeah, that was clear. Looks like this when we're done. Not too many foreign objects in there, which is a good sign. It means we never had a major compressor failure in the past. So this should be a good core. I think that this car had no refrigerant left in it because the O-rings may have failed or something else could have rusted up here. Every O-ring I've seen in this system has looked really gross, really permanently deformed. So yeah, I'll put some air through this one more time, and then this is a solid and it just evaporates. So we just let that happen. We've got ourselves a clean evaporator core. So now that we know the hose lingo and you know the numbers, the sizes, fittings, all that fun stuff, it's time to make our very first hose. Since this is an engine swap, we want to use a compressor adapter block right here. This is the Coldhose LS compressor adapter block right here. What it's got is it has a number 10 on the suction side and a number 8 on the discharge side. Those are O-ring fittings. So what we're going to do for the discharge side, that's what we're about to build now, our very first hose, is use the number 8. That is the one that is down lower. And what we need to do is go from our compressor all the way down into here, where I've got my custom fitting sitting over here. Now this is a custom fitting that Coldhose made for me. What I did was I took a Yukon hose, I cut off where I need it to fit into the condenser because the condenser uses special fittings. And what Coldhose did is they welded on a compression fitting for the hose. So I'll show you another one of those later, because we're going to use that for our liquid line. But that's one really great thing about Coldhose is they will make custom fittings for you based on your application. You can buy a hose, or if you already have the hose, just send it to them. Tell them what you want on it, and then tell them what you want on the other end. So here it is, the custom fitting. So I needed this right here where my finger is pointing, and that is where it's going to go onto the condenser. They gave me a new seal right there, and I didn't communicate this clearly enough. I did not need the pressure port. I needed them to terminate right here, but I think it's going to work out because what I was able to do was able to bend it into place a little bit, so that's all good. and then this goes in kind of upside down with the screw hole going upside down. And as you could see when I was showing earlier, it kind of angles it up just enough to where we're going to meet up with our number 8 on the compressor. So what I'll do is I'll get this seated in the condenser with a screw, and we'll get our hose out and start cutting it to length. Okay, so we have our condenser fitting installed. It's tightened loosely, but it's definitely a little bit tight. I want it to feel, you know, sturdy, solid. And same thing with over here. We have the straight number 8 O-ring fitting right here. And then right here I have 2 feet of number 8 hose. So what we're going to do is we're going to take one end of that, we're going to put it in here, and then you can see we've got a little path here to the condenser thing. So what I'm going to do is I'm going to take a paint marker, I'm going to mark maybe like right here about a ½ inch more than I think I need, and then I'm going to cut the hose at that point. Now this is the part where you want to make sure you definitely go longer than you think you need to go, because you only bought 2 feet and you only have 2 fittings. So if you make your hose and you crimp your fittings, you can't undo that. You can't get the hose back. You're going to have to go back to Coldhose and buy it a second time. Trust me, I've been there. And to cut this, I'm going to use wire cutters, like really big, heavy wire cutters. There are hose cutters, you can use that if you have them. This is just what I happen to have and it works really well for this. So I'm going to go ahead and cut where I put my little paint mark right there. In fact, I'll even go a little bit beyond it because I really want to make sure I have enough hose here. So let's take this back to the car, put it in the fittings, and see what it looks like. At this point it behooves us to take the fitting that's most easily accessible and use that to kind of remove. We'll put this on, and then we can put the fitting back in place. But again, you know, I knew this would happen because I did it on purpose. This is too long. It does not want to seat just right without a lot of force. So I need to shorten just another ½ inch or so, probably where I'd originally marked it. You know, make sure you don't lose your O-rings in all this. This one got stuck in my fitting, didn't come out, and then it was about to fall out onto the floor. And I'm glad I caught that. Okay, so looking inside, we've got the hose inside of the number 8 straight fitting, and the hose inside of the custom fitting down here. So let's check for clearance here. One thing we noticed is that we are quite close to our drive belt for the compressor. And I can kind of twist this hose in a way where I can use the natural bend in the hose to my advantage. Like, you know, I could have it this way. Now we're touching the belt. But then if I kind of twist it this way, well, that looks a lot better. So let's twist it really far this way so it's touching the frame rail. Well, whatever, it's unibody. And then we'll just kind of tilt it slightly out so it's not actually touching the frame rail. And then we have a pretty good distance from our drive belt. So at this point we're about ready to crimp this hose, and this hose is going to be done. But it's really important that we think about 2 things. One of those is what I was just talking about. You know, you need to make sure you know that when you're bending this around, you can get the curve in the hose to work in your favor like we just did. So you're going to want to mark your fittings with the paint marker like so. All we do is we just go with the marker, draw a line on the fitting and a line on the hose. We make sure the ink actually went down. And that's going to tell us how we had it when we go to crimp it. So we'll make sure those are lined up when we crimp with the crimp tool. And then over here, same deal. Take my marker and just draw a line. Can't tell you how important this is. This is very, very important. It might not seem like a huge deal right now because we have 2 straight fittings, but the minute we get into angled fittings, it's going to be so, so important. The second thing to consider, and this is one that I'm going to have to think about here, is when you crimp these, the hose actually oozes out a little bit. So the hose is going to want to leave the fitting by like an 1/8 inch or so once you crimp it, because it needs somewhere to go. So we need to make sure that it's not going to be too long to the point where we can't get this on the car. For that reason, I might remove like a 1/4 inch of hose from this before I put this on the car. This is the MasterCool 71550 AC manual hose crimper. It comes in this case, and you can buy it with these different die sets right here. They do make die sets for reduced barrier hoses, but I only have die sets for standard barrier hoses, so that's why we're making everything in standard barrier. So what's in here right now is the number 8 die set. You can see right here, there's little numbers on there. It tells you what number the die set is. It goes in easily, you just kind of drop this in and then kind of make sure it's in there. Same thing up here, kind of pinch it to get it out. Go like this to get stuff in. Then, what we do is we take our AC hose that we want to crimp. There it is. Before you crimp your part, you want to make sure that your hose is all the way in. You can see in these fittings, there's a little tiny hole right here. If I pull this hose out, maybe you can see it a little bit better. Maybe you can see light going through it, I'm not sure. But if we put our hose in, we want to make sure that in this little hole, we see that there is hose in there. And that means that our hose is completely bottomed out inside of this crimp fitting right here. So what we'll do after this is we'll go put it in the tool. We're going to look at our mark right here. This is a straight fitting, so it doesn't really matter that much, but I marked it anyways. Let's just do that for practice. So we're going to take that, put it down, and we've got a little locking pin. We're going to put the locking pin in. And you'll have to lift it up slightly to get it in. And there you go. So we're going to look and make sure that our metal thing is in the actual crimp part. We'll start hand tightening. Kind of bring it down. Okay, I feel it pushing back on me, so that means we're about to start getting a good crimp. So I feel it kind of pushing back on me. We'll start using a 19mm wrench. This is a spare tire wrench, a spare tire jack that I've had laying around. Happens to work great for the job. As you start to tighten, you can kind of twist your hose a little bit inside of the fitting. Make sure that you're looking to see that your white line here is lined up with your fitting white line. And that's going to make things go better for you. So, let's start finishing off the crimp. And what you'll do is you'll turn this until there's about an 1/8 inch right here. I see a little mark on here. I don't know if I did that or if that came that way, but that looks like a mark showing, where you should stop crimping. So I'll start backing this out now. And we can remove this. Look at that. A perfect hose crimp. We can see we still got rubber right in here. And since I shortened this hose, I can't prove it to you yet, but you would see a little gap here between your lines because the hose will have squeezed out. We can try that with the next one we do after we test fit this in the car and make sure we didn't do anything horribly wrong, so we can catch it while we can. Okay, I checked inside and everything looks okay. Now, it's time for the big moment. You see this line right here, that's what we put on our fitting, and we're going to make sure that we get those lined up just right. And there we have it. This is our very first air conditioning hose for our project. Hopefully it fits because, like I said, I wasn't joking. Look how much further out that is. That used to be almost flush, and now we've got like an extra 1/8 inch of hose because of what happened at the crimp there. So I'm going to go put this in and see what happens. So now that we've made our discharge line, which is the line that goes from the compressor to the condenser, because the compressor is discharging the pressurized refrigerant. Now we need to make our liquid line, which is the line that goes from the condenser to the dryer. So what we know is that we have this guy right here, and this is going to be going on to our condenser right in here, and it's going to come out in about this area. Okay, time for magic. Boom, magic. This is a receiver dryer. It's generic. I bought it from Coldhose.com. This one is special because it has 2 different pressure ports on it. You can put, I forget the thread size of this sensor right here, but this is just a Schrader valve, so we're just going to leave this cap on because it's not the size thread we need. We need M10 because that is what GM used for their pressure sensor on the high end for this particular application. This is my sensor. This is an adapter that goes onto the dryer. So adapter screws into the dryer, and then sensor screws onto adapter. We'll tighten these later. Just wanted to point that out. So now what we need to do is figure out where we want to put this. Let's first note that this says in right here, so we probably want the flow to go that way. I think that sitting it right around here will be pretty okay. I think this might actually work right here. Our dryer is going to sit a little bit sideways, but I don't think that's too big of an issue. We'll just make sure that we make our liquid line so that we can meet right up here. So this is going to be another very short, easy line. One thing I want to note about this line that you could do differently. We see right here this little thing. What is this? This is a high pressure port. So what this is this is my modified Camaro hose. This is where from the factory or at the garage they hook up the air conditioning manifold to add or release refrigerant. It's this one, the high pressure port. So you could have this, in theory, anywhere in your high pressure part of your air conditioning system. So like before the expansion valve, but I find that most of these happen pretty close to the condenser. So I thought that since this is a factory location, this would be pretty good for me. And when it's on the car right here, I have pretty easy access beyond this thing. You can't quite see it, I'm sorry, but I can get my high pressure hose right on here and read the high pressure when I add refrigerant to this. If you don't have a hose like this, there are splicers you can buy on coldhose.com. They're in the fittings section. You just need to figure out what size hose you're going to have, whether you want it straight, whether you want it bent. The low pressure tap we're going to look at, that's pretty interesting. It's a very cool fitting Coldhose has, but we'll show that later once we make the final hose on this thing. So if I didn't have this, I'd be splicing in a high pressure tap, is all I'm saying. So that's something you'll need to keep in mind if you're building your own air conditioning. You need taps for the high pressure and the low pressure. So now that the dryer is in place, let me get my custom fitting in place with the high pressure tap here. This one's great because it's got a little captive peanut thing here, so once we're in, I can kind of rotate this however I need it to be. When we get that off, we can put our number 6 straight fitting on the receiver dryer. Because when I was looking at this, I figured it would be best to run a straight fitting right here. So here's the number 6 hose. It says size 6 on it. We're going to need about this much. So I'll go make a cut. I know I made my hose a little bit long, so that's causing it to not want to meet up, but it looks like, I had this like this earlier. I forgot that I could go like this, and that actually makes a really comfortable bend into here. So I think I will shorten the hose a little bit. We'll find that this lines up great, and we can make the hose. So I think at this point, it could even be shorter too, so that's a good thing. Let's take our paint marker, draw a line through each one, and let's crimp it. We talked about putting the dies in. I've got the number 6 dies in right now, and they kind of come in like this. You got these pin thingies. You just gotta kind of make sure they're in there, and it stays. You can put this in whenever. This one's okay because we can fit this right in. But what I want to talk about is like how far do you go? So I read the instructions and I watched the manufacturer's video. The manufacturer's video, MasterCool, it's kind of vague. It wasn't very clear to me. It just kind of says, go until it's done. I'm like, but when is it done? So, if you actually read the instructions, what they tell you is that they want you to look for 1/8 of an inch between this one and this one. And that is when it's done. So, finger tighten until you're about here. You can't turn it anymore. Basically in there. Then just take your 19 millimeter and just start coming down with it. Do a few rotations. It looks like I added a little mark here. I can't remember if I did that or if that's from the factory, but that's just kind of showing the stopping point, if you will. There's a video of some guy on here using this with an impact, and well, it very clearly states in the instructions that you do not use this with an impact. There's plenty of tools that are like that. You know, I have spring compressors that I used with an impact on this channel, but you know, to each their own. This one, it's not that hard. I'm just going to use my hand wrench and do it that way. So there's our first crimp. We see our lines are lined up with one another, and look how much it came out. That's like a good 1/8 inch right there. So again, you got to keep that in mind when you're making these hoses. I know that this one is not really going to suffer too much from being too much longer. So again, there we are, lined up. Spray her down. There we go. And let's do it. Maybe one more. Is that about good? One more for good measure. And there we are. One custom hose. Let's put it back in the car and see if I made any mistakes. Would you look at that? Second hose in the car, ready to go. Not touching anything. And then while I'm here, here's a look at that high pressure tap. So I just gotta kind of reach into here. We'll put the hose right on it. You can see a little blue cap right there. Should work just fine. Let's keep moving on here. I called this the liquid line earlier. This is also the liquid line because remember, we don't have a vapor phase change inside of the dryer. What we're about to do now is we're going to go to the expansion valve. And I've got something in there right now. You see this line right here, this stainless piece? This is the factory liquid line right here. It's a very long stainless piece. And it goes all the way down here. You probably can't see that movement, but now you can. See? So it'd be a shame to not attempt to reuse that. There's a Jaguar website out there that talks about how you can use this with a union fitting. So you just put a union fitting on the end of the stainless, get different stainless, and you're good to go. I asked Coldhose about this, and they said, well, we only do that for temporary fixes per se. It's not really recommended for permanent solution. So here's what they sent me. This is a crimp-on fitting that we're going to be able to weld directly to this stainless line. Can I do that? No, I don't have the tools, but my neighbor does. So we're going to get this length right. We're going to look at this and see, okay, now we got to come down out of here, take this cap off. We can either go straight down with this 90-degree fitting and just kind of put a right angle in that stainless tube, or we can take a 45-degree angle and just kind of meet it slowly, if you will, kind of over here. So I liked this idea the most because I don't like making like super sharp bends and stuff, especially if we're going to be bending stainless tube. We don't want to bend it too much. So we're going to try to put a bend, I don't know, in there, and then we can kind of follow this path up to here. We're just trying to visualize this, you know, how can we, what's the best way to get here? We could also cut all the way up here because I bought enough hose. I'll think about this and let you know what I decide. I'm just showing you kind of a glimpse into the thought process. You know, how are you going to go about this? How are you going to take this path inside this engine bay, make it look clean and be, you know, out of the way of things that get hot and stuff. So here's the nice bracing job my neighbor did with an oxyacetylene torch. I really appreciate him and thank him very much. So now I'll go get this in the car and I'll show you kind of what I was thinking. I added this bend right here. I'll show you how that kind of works out in the car. So there it is on the expansion valve. It comes up and around, and then it goes down into the engine bay. And we're going to come out right in here. You see I've got that crimp right there. What I can do is I can put the hose there. It'll kind of come up and meet up with this right here. So you can see the path. We'll grab the hose, we'll cut it to length and see what it looks like. There it is, going from the dryer to the expansion valve, and we're going to do that with a combination of the original Jaguar solid line and this little flex line we added right here. Now I don't know if I've noted it, this line is stainless steel, So I had Coldhose send me a steel crimp so they could be brazed together. I guess you could try welding, but my neighbor is very experienced with welding and brazing with the torch and stuff. He thought this was the best way to do it, and I trust him. Now it's time to mark this with the marker, crimp it, put it in, and we'll get the suction hose created. Now it's time to get ready for the final hose, the suction hose, which is the hose that goes from the evaporator core to the compressor. This is where the refrigerant has been heated back up, per se, or it absorbed a bunch of energy from inside the car to make the car cooler. And now we're coming back to the compressor so I can do the cycle all over again. So right here you can see I've got a 45-degree number 10 fitting on there, and that's going to allow the hose to kind of go up but then kind of go along the firewall there. And then we got to come back down into the engine bay, and you can see we got to make a pretty quick bend here because the compressor manifold wants to go toward the front of the car. So what do we have? We have this fitting from Coldhose right here. This is a number 10 135-degree fitting with a low pressure tap on this side. They sell this with the tap on the other side depending on your application, but I figured this will work well for me because I can put this in like so. So then I'm making this bend, you can't see it too well, but we'll come around with the heater hoses, and then I just kind of got to move my heater hoses out of the way, and I can get my low pressure tap right on there instead of adding a splicer into this really big hose and having it be really obvious and just kind of hanging out. This makes it kind of hidden, a little bit cleaner looking, and I think it'll be pretty awesome. So, you know the drill. Just take the hose, put it in there, put it down there, cut it to length, make sure everything works. It's going to be especially important to make sure we use the paint marker very carefully with this one because we have two angled fittings. I think everything else has had at least one straight fitting on it, so it's not as crucial. This has two angled fittings, and this hose does not twist. It is very stiff, very heavy. So make sure you get that right before you do your crimps. So here it is, everyone. Here are the 4 hoses that we need to run our air conditioning. Let's start from the very beginning. We've got the suction line. This goes right from the compressor here all the way to the condenser. It's got a sensor port that we're not going to use, so don't worry about that. Then we come off of the condenser right here. We've got a high pressure tap for the refrigerant, and then it's going to go all the way down to here where we connect to the dryer. The dryer has a fitting for our pressure sensor, so we can read the high pressure side. That's what the computer needs. Then if we come off the dryer, we're going to this liquid line. We're going all the way down. This is the original Jaguar stainless, and then we go to the expansion valve right here. The expansion valve is directly on the evaporator. Then we come off of the evaporator right here, and we make our way all the way through the engine bay back to the compressor where we find our low pressure tap. So there it is. So we're about to put the hoses on the engine, and there's one extremely important thing that we need to remember to do when we're doing this. We need to lubricate these O-rings because, these things are about to see pressures of up to like 300 or 400 psi, at least on the high side. So you want this steel to be dang good, but what kind of lubricant do you use? Well, the old R12 systems all used mineral oil, and these new R134A systems, they use something called PAG 46. And that oil is going to do is it's going to try to take in as much moisture as possible. Not necessarily something you want on your seal. So what we're going to do is we're just going to take the O-ring off, and this is just good old mineral oil. I got this on Amazon to shine up one of my cutting boards in the kitchen. Maybe you've got it laying around, and then just take like a little solo dish thing from your takeout, and just got like a little tiny bit in there. Just dip the O-ring in it, and then put it back on your hose, and then you can secure your hose to the thing. And that's going to allow the O-ring to kind of stretch out and move smoothly along the metal surfaces that it's sealing against. If this is dry, especially on the case of this dryer here where we had to spin the sensor on, the O-ring itself was rotating to create the seal. So it's especially important on stuff like this. Whereas with these, it's just moving in. This O-ring is not rotating. This nut here is doing all the rotating. So just something to definitely keep in mind if you want to make sure you have a good seal, because we're about to pull vacuum on this when we're done. If there's not a good seal in this system, we need to find it immediately, and it might not be easy to find. So let's keep going here. Alright, this is very exciting. All 4 of the hoses are in the car. You can see we've got the suction line and the liquid line right in there. They kind of all blend into this mess here. And you know, we've got a receiver dryer right there, and there's more stuff going on down there. What's added now is the refrigerant pressure manifold gauge thingy. You can get this at Harbor Freight, that's the one I'm using. And we're gonna just kind of look at how we have this plugged in here. The blue hose here is for the low pressure, and the red hose is for the high pressure. The yellow hose is for either the vacuum we're gonna pull or the refrigerant we're gonna add. So right now, I have my vacuum pump set up so that we can pull a nice solid vacuum on this. I'll do that in a minute. You can see we've got some valves right here, open and close. We're going to start with these closed right now, but I do have the valves on the actual ports open. If you look in here, you can see there is actually a valve on this port right here. I've got this open. You see that? The low pressure is the same way. By the way, I regret my design decision putting the port right here, because look how much I gotta bend this heater hose just to get that on. So when we go to actually turn the car on and start adding refrigerant, the engine's going to be running, that hose is going to get hot, and it's going to be a little painful getting that fitting off. So, you know, learn from my mistakes, don't do something like that. Anyways, I have the vacuum pump hooked up, so we'll go ahead and turn that on. It's a little loud. And now what we're going to do is we're going to open this by turning it counterclockwise. And you may see the vacuum dip down a little bit as we open. Yep, there we go. Sucking in vacuum. And then we're going to open this one as well. We can pull vacuum from all sides. I want these as open as possible. Okay, as you can see, we're kind of creeping down toward 30 inches mercury vacuum. And we just want to let this run for a while. You know, maybe like 15 minutes. And that's going to pull the most solid vacuum possible, make sure all oxygen, moisture, all that fun stuff is out of the system. And then once we're done pulling it, we're going to close these valves, turn the pump off, in that order. Okay, close the valves first, that's important. Then we're going to watch that gauge further and make sure it doesn't creep back up. If it creeps back up, that means we have a leak in the system. And if it stays there, it means we've got a sealed system. So we're just going to let this run for a little bit, and I'll come back when it's time to take a look. And we see that the vacuum gauge, or pressure gauge, whatever, is not moving. So that's very good. We're going to wait like half an hour and make sure it doesn't move, so we're dang sure we have no leaks in here. So now it is time to add refrigerant to the car. This is what we're using, R134A. Became standard in the early 90s. It's refrigerant. And it's got a little thing right here. We're going to need to buy one of these guys. This is a little fitting that's got a little needle controlled by this guy here. You just kind of screw this on, and what's going to happen is once this is screwed on here, when I tighten this down, I'm going to get refrigerant moving through here. This is the future. That didn't go well. Putting refrigerant in didn't go quite as I planned. I went a little too fast. I realized I forgot how to do a lot of things. And what I'm going to do is I'm just going to link a video to a more professional channel that did it right in the description. So if you want to know how to properly fill your car with the refrigerant, go watch that video. I recommend you do it. They explain it a lot better than I was able to in whatever I recorded that I'm not putting in here. Okay, so here we are. It's working. I added about 4 cans. Well, added 4 cans. The amount of cans you'll need is dependent on your system. I don't know how much you'll need. But you can see that fog right there. Inside this Jag, it is ice cold in here. It is working. That is awesome. Oh, and my tachometer is working too. That wasn't working earlier. So for these pressures, I've got a little chart that I've gone off of before. I don't exactly know what the ambient temperature is in here, but if it's hotter than I think it is, this might be a little bit low, but it's working. And these pressures don't seem bad, so I'm just going to leave it. I'll add the other can if I find that the performance is lacking or something. There's the proof, everyone. He's coming out cold. I'm pretty happy. It's going to make this car very enjoyable. One thing that I nearly forgot is that we need to put some cork tape on the expansion valve. This is the part number. Coldhose sells this. And what it is it's basically a rubbery cork tape type thing that you put over parts that get cold and develop condensation on or have the tendency to. So this is especially important if your expansion valve is inside of your car, because if your expansion valve is getting cold and there's water condensing on it, that water might end up on your feet or inside the front of the car somehow, might not get drained properly. If you put this stuff on, it's going to keep that from happening. So here's the stuff out of the bag. You know, it's pretty sticky, kind of nasty, but it doesn't really stick to your fingers too much, so that's kind of nice. You're just going to want to peel this off and just kind of wad it up and just cover any areas like this in this rubber cork tape stuff. If you look at it from the other side, if I zoom in, you can kind of see where the old stuff is. So, you know, this entire area was covered in this cork tape. So I've got some tape ready here. I'm going to go ahead and kind of get that on, cover all this up. I'll show you what it looks like when it's done. So, you know, you used to be able to see all that copper expansion valve stuff, and now you can't. The idea is you're basically covering all that stuff that it's potential to get cold, so it can't drip on anything. And I waited until I knew that the system was working before I did this, because, you know, it would be kind of annoying to have to undo all that gunk just to check to make sure you don't have a leak back there. That was about 3.5 foot of that stuff. So that's really the final step here. We've got a functional air conditioning in this vehicle. Very awesome. So that is it. Thank you so much for watching. I am so thrilled to have taken you through this journey of getting air conditioning working in this vehicle. I hope that this video helps any of you who are looking to do this to your own car, especially if it's custom, and that the tutorials on Coldhose and, you know, how this all works, how you get it to work, how you build it, is very helpful for you. Thanks again so much to coldhose.com. I will see you in the next one.